This is Unit 4 modeling. We're on day 2 creating quadratic functions. Really what we learned yesterday with actually solving 3-variable system of equations, that's going to come into play today whenever we look at modeling quadratic functions. Now on this first one it says determine the maximum of the quadratic function that has these points. And you'd see a set of points here and you're like, alright, well evidently it's going up from 5 to 6 and then it's going back down from 6 to 3. And some people would assume that 6 is your maximum value. This would be incorrect. What we actually have to do is actually create a function to represent these points, and then we can apply axis of symmetry and plug that value back in to actually figure out our maximum. So let's get going on the process. What these 3 points do is they allow us to create 3 different equations. Remember that y equals ax squared plus bx plus c. And what happens here is we can actually plug in x and f of x. So really I'm using f of x. Let me make that correction. Alright, so let me use the point negative 2, 5. I'm going to put 5 in for f of x. A times negative 2 squared for x plus b times negative 2 plus c. And that's going to be 5 equals 4a minus 2b plus c. And if I was to make a 3-variable system of equations, that would be the first equation. 4a minus 2b plus c equals 5. From that right there, using my first coordinate. And we don't know what a, b, and c are, but we will make 3 equations so we can solve for the 3 unknown variables. Now where are those other 2 equations going to come from? They're going to come from the other 2 points. So let me go ahead and do the next point of putting in negative 1, 6. So 6 equals a times negative 1 squared plus b times negative 1 plus c. So I'm going to have 6 equals 1a after I square the negative 1 minus b plus c. It's my second equation. A minus b plus c equals 6. And now let's get a third equation by using the last point, 0, 3. This is actually going to be really the nicest. So 3 equals a times 0 squared plus b times 0 plus c. And actually, a times 0 squared will just be 0a. B times 0 will be 0. So we're just left with 3 equals c. Alright, now I have a 3-variable system of equations ready to be solved. Now once I do this, I'll have a, b, and c, and I'll have my function, and then we can actually get to doing the problem. Alright, the nice thing here is I actually already have one of my variables. C is 3. So I'm actually going to substitute that in for these first 2 equations to change it to now 4a minus 2b plus 3 equals 5. And that will change, and I'll change that to 4a minus 2b equals 2 because I subtracted the 3 from both sides. I'm going to do that same process for the second equation. So a minus b plus 3 equals 6. I'll minus 3 from both sides and I'll get a minus b equals 3. Now I've got a 2-variable system to solve for. Personally, I would say just use elimination. I'll multiply that second one by negative 2. That way the b's will cancel. So my equations would now be still 4a minus 2b equals 2, the first equation. This one will now become negative 2a plus 2b equals negative 6. And so I've got 2a, b's cancel, equals negative 4. A is equal to negative 2. Alright, so let's circle up things I've got. I've got C, I've got A, I need B. So to find B, I'll use the A minus B equals 3 that I had earlier. A minus B equals 3. I'll use that one right there. So A is negative 2. That I just found. Add the 2 over. And B would be negative 5. Alright, so here's our three things, and now we finally created a function. F of x equals negative 2x squared from my A value, minus 5x from what B was, plus 3. This describes my quadratic function. Now I can finally get to figuring out what the maximum is by doing negative b over 2a. This will find axis of symmetry, and I'll plug it back in. So this is going to be 5 over 4. Now I'll plug that back into the function to actually figure out what the maximum value is, f of 5/4. And I'm definitely just going to use a calculator here to speed things up. So let's go and type that in. Small correction here. This should have been right here. Positive 5 over negative 4. Excuse me for my mistake. So this will be f of negative 5/4 that I'm finding here. So these should have been negative values. So negative 2 times negative 5/4 squared minus 5 times negative 5/4 plus 3. So you should have gotten, as your final answer, 6.125. Your maximum value, 6.125. And now I have a few things circled up here, so you'd want to make clear that this is your answer. These things over here were not my answer. I was just kind of circling up things I was contributing. Quite the process, you can see, to figure out what a maximum value is. Can it be done easier? Yes. So I'll get to that now. Alright, so we don't really need to go through the process of creating a three-variable system every single time we do this. The calculator can actually use matrices to actually accomplish this for us. What you need to worry about is the calculator can do the work. What I'm going to do is I'm going to take this table and I'm going to drop it into Stat Edit. So I'm going to click on the Stat key and hit Enter on Edit. This will allow me to edit my lists. Consider list 1 right here to be your x values. Consider list 2 to be your f of x values. So I'm just going to put the table in with my x values of negative 2, negative 1, and 0. And I'm going to put my f of x values in of 5, 6, and 3. Once you've got those entered, what the calculator can do is actually calculate a quadratic function for that by hitting on Stat again and going over to Calculate. At the top of the screen, you'll have to hit to the right. And now you'll actually select quadratic regression, which is the 5th option down. When you do that, you can tell it to use list 1 as its x values, list 2 as its y values. You don't need to worry about frequency lists. You don't need to worry about store regression. All you have to do is just go down to calculate. And you can see that it gave me the values of A, B, and C with absolutely really no work compared to what I did just a moment ago. So y equals, well, let me actually use f of x. F of x equals negative 2x squared minus 5x plus 3. Now you can see that that was a lot quicker to get my function. Now I would still need to go through, follow through here, and actually get my final answer of 6.125 by using negative b over 2a and plugging that back in. But please keep in mind that the calculator can do quadratic regressions. It's a lot easier, less chance for a mistake. I know you're probably mad at me because I didn't show it first, and you're like, why the crap did I do this three-variable system? Well, it was good for you. You needed to see it. So there you have it. Just to give you a heads up, there is an example 2 that we're doing in class that I'm not going to get into with the video because it takes kind of me being there. So if you have questions on what was going on with that, just ask me during a tutoring session. I'll help you out. Moving on to our last one, example 3, seats closest to a theater amphitheater stage. Section A costs $30. So those are the best seats. Then as you go into further section away, section B, they cost $25 less expensive. Then the lawn, which is where I sit for concerts, are $20 a piece. And those are my people. They're there to have fun, and we're back in the lawn, and we're having fun. But there are twice as many seats in section B as in section A. When all 19,200 seats are sold, the amphitheater makes $456,000. How many seats are there in each section? So what we're going to need to do is let's define some variables. I'm going to make A the number of seats in section A. I'm going to make B my number of seats in B. And for my loan, I'm going to let my loan tickets be C, just to make it kind of easy here. And since there's three unknown values here, we don't know how many seats there are in A, how many seats there are in B, how many seats there are in the loan. We're going to need three equations to solve this. So let's go ahead and get started. My first equation, that's a sorry looking bracket, but you're just going to have to deal with it. Well, maybe I can make it better. That's a little bit better. Okay, so my first equation is going to come from actually the fact that there are twice as many seats in section B as there are in section A. So what I'd have to do is I'd have to double the amount of section A to equal the number of seats in section B. That way there's twice as many in B. Sometimes people want to do the wrong thing in doubling B. That's incorrect. If there's twice as many seats in section B, you'll have to double A to know how many seats you've got in B. All right, now let's go ahead and move to this little fact. When all 19,200 seats are sold, that's the total number of seats. That's if you did A plus B plus C. That would equal 19,200. And now moving on to another equation, and this last equation is kind of a little curveball here, but it's actually coming from the money. If the section A is bringing you in $30 per seat, $30 for every seat in A, and you're going to get $25 for every seat in section B, and you're also going to get $20 for every loan ticket that you sell. The total amount of money that you're bringing in is $456,000. And there's our three equations. We'll actually solve this system here. To do that, what I would personally do is I'd go ahead and substitute in for B on both of these equations. And actually, at the very beginning, I would divide out a common factor of 5 right here to make it a little bit less big as far as the numbers go. So I'm going to change that third equation really quick to 6A plus 5B plus 4C equals 91,200. Again, I took every single part there and just divided it by 5 on that last equation just to make the number smaller. Now what I'm going to do is I'm going to replace B with 2A both here and in this equation. So 6A plus 5 times 2A. And what I'm going to do is go ahead and say, well, that's 10A. 10A plus 6A is 16A plus 4C equals 91,200. Now what I'm going to do is I'm going to replace B yet again, but on this other equation, since I can. So I'll have A plus 2A plus C equals 19,200. And A plus 2A is 3A. Now I'm going to work with these two equations, seeing what I can cancel. Personal preference would lead me to actually just multiply this one by -4. That way the C's will cancel. So that's what I'm going to do really quick. I'm just going to multiply that whole thing by -4. So I've got -12A minus 4C equals, and I don't know that off the top of my head, 19,200 times -4. It's going to be -76,800. All right, now I'm going to bring up this other equation from down here and write it underneath it and use elimination. Let's go ahead and add the two equations together, and my C's cancel. My A is 4A equals 14,400. When I divide both sides by 4, I get 3,600. So that's my seats in Section A. Section A has 3,600 seats. Now, as far as the other two sections, they're really, really easy because, remember, 2A equals B. So I can just double that, and I get that B is 7,200. And now, I just need my lone seats, and what I would do is I'd refer back to this. The A plus B plus C equals 19,200. I would plug in 3,600, right here, 3,600 for A. I'd put 7,200 in for B, and I'd take both of those away from 19,200. So 19,200, take away 3,600, take away 7,200, is 8,400 seats in the loan. So there's my loan. Here's Section A. Here's Section B. And there's my three answers. That's how many seats are in each section. Just a nice little word problem. You can have all sorts of different situations where systems of equations are useful in word problems, but here's just one. If you got any questions, let me know. Don't forget my tutoring sessions, and thank you very much.